So here is an example. It says a resistor in a circuit draws 3 amps. So I can write down that I equal 3 amps. And then with a battery of 12 volts, so I know that V is equal to 12 volts. What power, so I'm required to calculate power, that's my unknown, is dissipated by the resistor. If we go here, let me move my face, if I can move my face. Can I move my face? I'm stuck over here. Okay, so if we go back here, so the equation is P is equal to IV. That's the right equation to use. So P is the unknown. That's what I'm interested in calculating. My current is 3. And then my voltage is 12. So if you multiply, you can use your calculator for that. If you multiply 3 times 12, you're going to get 36. So this is 36 watts. Okay? So let's stop. All right, we're going to continue working on our problems. I just turned off the camera so we have more room to show up this part. It wasn't that good on the previous slide. So here the problem reads, a light bulb connected to 120 volt outlet. So I know that V equal 120 volts and draws 0.5 amp of current. And then I know that I equal 0.5 amp. And then the question is asking what is the power consumed. So I am looking to calculate P. I'm going to go to our diagram here. I need to calculate P, so that's what I'm interested in. So I'm going to be looking into that quadrant. And then I have I and V. So I have I and I have V. So my equation is going to be P equal to I V, which is going to be equal to 120 multiplied by 0.5, and this is going to be 60 watts. All right, so let's go to the next problem. Again, this time it says 1200 watt hair dryer. So my P is equal to 1200 watts. Is connected to 120 volt outlet. V is equal to 120 volts. And then it says it's asking for I. It's asking for I. How much current does it draw? All right, I'm going to go to my diagram. I want to calculate I. So I'm going to be in this quadrant. And I have P. Okay, and I have V. Okay, so then I can say that I is equal to P over V, which is going to be equal to 1200 divided by 120, which if you can cancel these out, then 120 divided by 12 is 10 amps. Okay, let's do the next problem. A home stereo drives energy from 120 volt source. So my V is equal to 120 volts and draws 0.8 amp of current. So my I is equal to 0.8 amps. And then it says how much power does it consume? That's the first question. So P is what I'm looking for. So we're going to go back here into this, and then I'm going to be into that quadrant because I'm looking for P, and I have I and I have V. So P is equal to V times I, which is 120 times 0.8, And if you use your calculator, type on it 120 times 0.8, this will give you 96 watts. And then let's go back to the question. So the question, it says, if we want to connect this stereo to our car, how much current would the stereo draw? So the first question now is, we're connecting this stereo to our car, so V, the voltage of a car battery, let me change the color of the font. So the voltage in the car battery is typically 12 volts. Okay, and then now I know P is 96 watts, and I want to calculate the current, which is I. So I'm going to go into our circle. I'm interested in calculating I. I'm in this quadrant. So I have I, and then I have P and V. So I is equal to P divided by V. Okay, and then it's going to be 96 watts divided by 12 volts. And I believe this is going to be 96 divided by 12 is going to get you 8 amps. I will be equal to 8 amps. Next, all right, I'm back. I just added the this diagram which was missing. So let's go back. Here it says a 9-volt battery. So my V is equal to 9 volts. Is connected to a resistor that is dissipating 50 milliwatts of energy. So P is equal to 50 milliwatts. And if you remember, 50 in millis is 10 to the minus 3 watts. What is the resistance of the resistor? So I'm looking to calculate R. I'm going to go to our diagram, and then we're going to be here in this quadrant. I have V and I have P. So it's going to be this part. So R is equal to V squared over P. So if we plug in the numbers, V squared is 9 squared, and then divided by P is divided by 50 times 10 to the minus 3. And then if you grab our calculator, that's going to be 81 divided by 50, and then my answer is going to be in kilo ohms, which is going to be equal to 1.62 kilo ohms. All right, next. So next we talked about this, a multimeter to measure the power. It's going to be practically measuring two things. It's going to be measuring the voltage, and is going to be measuring the current. Oopsie, I erased this. Let me get rid of this. And it's going to be measuring the current. And then inside the multimeter, they're going to do the math. It's going to be programmed to do the math and multiply 13.6 volts times 970 milliamps to calculate the power in watts. Maybe we might as well do it. So if you grab your calculator, you take 13.6 multiplied by 13.6 times 0.970. It's going to get you 13.2 watts. Okay? So we talked about what you pay at home is you're paying in kilowatt hours, which is a unit of energy, same as very equivalent to joules, very equivalent even to calories that the biologists like to use. It's a unit of energy. Electrical engineers like to call it kilowatt hours, but it's the same thing. All right, you can get. Okay. So, energy consumed in watt, in kilowatt hour, is going to be your power in watts multiplied by the time. Okay, in hours. Here it's the same idea. Joules is joules per second. This is watts multiplied by seconds. The seconds cancel out and you get joules. So energy consumed, this is my final equation. Let's put it in a box. Okay, energy consumed in kilowatt hours is the power in kilowatts multiplied by time in hours. So let's do a problem. A 200 watt halogen light is left on at night for 8 hours. So I know my P is 200 watts, and I gotta be careful in units because I need my power to be in kilowatts. And then my time T is 8 hours. So energy consumed is going to be equal 200, and I'm gonna divide by 1000 to make it kilowatts, multiplied by my time, which is 8 hours, no conversion needed. So this is going to be 0.2 multiplied by 8. Grab your calculator, and 0.2 times 8 is 1.6 kilowatt hour. All right, a problem. Stereo is accidentally left for 7 days. Pretty long. 168 hours. While a couple goes away, it is rated at 0.8 amp and is connected to 120 volt supply. How much energy does the stereo consume during that time? So that's a trick problem. First step, you need to calculate the power in kilowatts. Remember the units. So P is equal to IV. So my I is this, and my V is this. So it's going to be a 0.8 multiplied by 120 is going to give you 96 watts. Next, the energy consumed is going to be 96 divided by 1000. So I get things in kilowatt multiplied by 168 hours. All right. And this is going to give me, all right, grab your calculator. So what you do is you 96 divided by 1000. That gives you 0.096 kilowatt multiplied by 168. That makes it 16.128 kilowatt hour. All right. All right. So now for energy cost is basically you calculate the rate, which is the electrical company charge, times how many kilowatt hours you use. Okay. And typically the energy cost is charged as dollar per kilowatt hour. So if you multiply dollar per kilowatt hour times kilowatt hour, which is the energy consumed by your meter, these two cancels out and you end up with dollar only, which is the money you're going to pay to the electrical company. So here's a problem. a 200 watt halogen light is left at night for 8 hours. It has been determined that 1.6 kilowatt hour of energy has been used. All right, so he saves you the pain, and he did the math already, and he tells you this thing consumed that much energy. How much does it cost to run the light for that amount of time? For the utility company charges 15 cents per kilowatt hour, which is $0.15. So here is the equation. I know my rate is 0.15. This is my rate. And then the kilowatt energy consumed is this, which is 1.6. So if you multiply both, you're going to get 0.15 times 1.6. It's going to get you 0.24. I'm sorry, $0.24. Okay? Next is the same idea. Stereo accidentally left for 7 days. Same problem we did before. Consumed 0.8 hours. 120 volt supply. Remember, to calculate P, you multiply this by this, multiply this guy by this guy to calculate P. Okay, and then you take these two and then you multiply them by this to calculate the kilowatt hour. So to save the pain, here is the kilowatt hour consumed. Okay, how much does it cost to run the stereo for that amount of time if the utility company charges 10 cents per kilowatt hour? So my rate is 10 cents, and the kilowatt hour consumed is this, which is 16.128. If you do the math, it's going to be $1.6128.